A bond strength of 436 kilojoules per mole means that breaking 1 mole of those hydrogen-hydrogen bonds requires that much energy under standard conditions. Think of a bond like a spring, holding 2 atoms together, and bond strength tells you how stiff that spring is. A value of 436 kilojoules per mole means the hydrogen-hydrogen spring is relatively strong compared with many other single bonds. So you need to add that energy to separate the 2 hydrogen atoms. When we say the same amount of energy is required to break the HH bond, we mean that if you have 1 mole of hydrogen molecules, removing the bond in all of them requires 436 kilojoules of energy. Energy values like this let chemists compare how much heat or light is needed to break different bonds, and they help predict which reactions will release or absorb energy. Remember that the number is a bulk value for a mole. So for 1 single hydrogen molecule, the energy is just a tiny fraction of that mole value. Students often think bond strength equals bond length, but shorter bonds are usually stronger, only as a general trend and exceptions exist, so check both properties rather than assuming one tells you everything. Look up or calculate both when comparing bonds. Another common mistake is mixing up bond dissociation energy with reaction enthalpy. And the quick fix is to remember that bond dissociation energy is the energy to break a specific bond, while reaction enthalpy is the net energy change for the whole reaction. People also forget units and the mole concept. So always note that kilojoules per mole refer to bulk amounts and convert accordingly when thinking about single molecules. For more clear videos and practice resources on bond energies and molecular calculations, visit www.gumballdegree.com.